Next comes the logical design of IoT. We have seen a physical design of IoT in the previous video. Now we will see about the logical design. It illustrates the assembling and configuration of the components. What is actually the functional block and how communication is made, and how the user are using with the help of the application interface. These things we will be seen in the logical design. So these three things we are going to see: functional block, communication model, and communication API. This is the diagram for logical design. So first thing is functional block. So functional blocks are nothing but it will provide the sensing, identification, actuation, management, and communication capabilities of the ecosystem. It can handle the communication between the server and the host. Why we are using this is just to monitor the control functions. It will manage the data transfer, and it will use a secured IoT system with authentication, and it will provide interface for controlling the data. It is actually more crucial part of the logical and physical design of IoT. The functional blocks, we have device and we have communication, manages the communication, and we have services and we have management and we have security, and we at last we are using it for application. IoT communication model. The communication model of IoT are used for communicating between the system and the server. We have three types of model here. One is request response model, where it actually works as a client server model. The client will send the request to the server and the server will respond back to the client. This will happen with the help of the HTTP protocol, that is hypertext transfer protocol. So this is the basic diagram of the client sending request to the server, and the server will send that response to the resources. It will match the data according to the client request, and it will respond back to the client. And the next is publisher subscriber model. This model is made up of three entities. One is publisher, brokers, and consumers. Publisher are nothing but it is a source of data. It sends data to the topic. Consumers, they subscribe to the topic and they accept data from publisher and send it to the consumer. Sends messages to the topic. According to the topic, the subscriber will subscribe. The real life example we can say is which we are doing it in Twitter. Publisher here is user, where they will post tweets which are published to the Twitter platform. Subscribers, which are all the followers of the user, subscribe to their tweets to receive updates. Topics are nothing but each user tweets can be considered a topic. Subscribers receive updates for the topics they are interested in. And the next is message broker. Message broker, here Twitter's backend infrastructure, which actually acts as the message broker, which will route the tweets from publisher to the subscriber. Message is nothing but each tweet is a message which is established or published by the user and received by their followers. And the last model is called push-pull communication model. It is a communication model in which the data pushed by the producers in the queue and the consumers pull the data from the queue. And the producers are not aware of the consumer. The same way the consumers are not aware of the producer. Say for example, when we visit a website, we saw a number of posts that are published in a queue, and according to our requirements, we click on the post and start reading it. So, and the last is exclusive pair communication model. It is actually a bidirectional full duplex communication which uses a connection between the client and server. First setup is a connection between the client and server and remain open until the client sends a close connection request to the server. Once the setup connection is on, the client is can send n number of requests until the client is closing the connection.